Okay, I had a few questions about the homework. When your program runs, it will do the following. Okay. Basically, you are constructing a number of tetraminos, and of course the number will be given by the user. You are gonna put them in an array or in a vector or whatever it is. Okay. So the step number 3. Okay. It is not playing any Tetris game. It is not trying to fit pieces in a Tetris board. There are no Tetris boards in this homework. Tetris board will come in the homework number 2. So even if you have 20 okay, tetraminos, it will be placed horizontally as good as possible. So nothing is going to be put on each other. Are you done? Nothing is going to be put on each other, and it will be all horizontally sorted and fit together. Okay. Good. So let's go back. We looked at this 7.4, which was bank account, right? This one. Later we said that we can inline some of the functions, simple ones, okay? Like this one. Get balance is a very simple one. I am just inlining it. Remember, inlining means inlining means implementing your function inside the class definition, or putting a keyword inline at the beginning of your function implementation outside of your class definition. Okay, so that will be inline version of it. What else I can say here? Of course, we put our consts keywords in the proper places, and that will be it. So 7.5 is something like that. And let's go to the slides. Okay, did everybody sign their names? Did you guys sign your names? Okay. So reminder. So let's go back to our discussion of object-oriented techniques and parameter passing methods. I am not going to say anything new in this one. We already talked about it, but let's make a review. Like any type, like integer or double, I can pass my object type arguments to the functions by call by value or call by reference. Okay. Call by value and call by reference, of course, their cost is different for large objects. Okay. Let's say in my bank account, let me go to my bank account. Let's say in my bank account, I have more than 2 integers and 1 double. Let's say I have 1 kilobyte of data. Okay, I am keeping the personal information, the person's address, the TC kimlik numarası, and etc. Lots of data about the bank account. Okay, so if I pass this object using call by value, is going to be expensive, because every time I send a copy, okay, I need to make a copy. So he's going to do that. My CPU is going to do that. So that's not going to be good. So what am I going to do? I will send it by reference, call by reference. Call by reference is very efficient because it doesn't send a copy. It just uses the same object for the functions too. Okay, that's what we say. But the difference between call by value and call by reference in terms of efficiency, in terms of CPU usage, number of cycles you spent, is almost the same because, I mean, call by reference is not free. You have to send something. You have to say, this is my object, this is the address, etc., right? And call by value copies the value. So the cost of sending a reference and cost of sending the value is the same for fundamental types. For integers, doubles, booleans, floats, characters, and etc. Okay, the difference is the same or negligible. So that's what we do. If we send a fundamental type to a function, we send them by call by value. Okay, and if we send an object type like bank account or any other object, okay, day of year, we send them call by reference, but this time we are concerned about object being changed by accident or by another reason. So we send it by const call by reference. Okay, that's the rule. Okay, large data types, we pass them call by reference, but we make them const to protect the argument. Okay, this makes parameter read only, and if in that function by mistake if I change that parameter, then I am going to get a error message from the compiler. Okay, good. So we already knew this, and we did that. So these are the, remember, my bank account, my output, my get balance, get dollars, and get cents. They all will be consts. Okay. Okay, question for you. Let's go back to our bank account. Okay, as you see in this one, in this example, yeah, I have, okay, good, these are consts. That's good. So let me go to, I think I asked this question, but I'm going to ask it anyway. Let's go to the input function. Where is my input function? Okay, after the input, can I call out, can I call output? I think that was the question I asked you. And remember, output is a const, and I can do that, right? Why? Because input says that I may modify this object, and it's modifying it. Output says that I am not going to modify it, so this is okay, right? This is okay. But if I do just the opposite, where is my output? My output is here. If I do this output, I will get an error message, right? This will be an error message. Sorry, input. Okay, so this will be an error message. Why? Because output is not a const function. Output is a const function. I forgot to put const in here. Okay, and it promises that it's not going to change anything on my input, and I am getting an error message in this case, right? In this case, how about this? How about this? I forgot to, let's say, okay, this is an error message. Let's say I forgot to put const in get cents, although I am not modifying anything, okay? I am not modifying anything in get cents, I am just returning a value. I forgot to put const in there. The compiler will not say anything, okay? You compile get cents, it works, okay? You forgot to enforce the principle of least privilege, right? How about this? In my output function, can I do this? Is this an error or not? Just everybody take their time. Okay, did you understand the question? Input definitely produces an error because it modifies the object, and this is output promises that I am not going to modify this object. Now I am calling this getSense function. I mean, regularly, I mean, of course, you can print whatever you want. You are not modifying anything. GetSense is a const function. But I am saying that I forgot to declare GetSense as a const function, and I am calling this GetSense in output. Is this a compiler error? Should this be a compiler error? Those of you who says, yeah, this is an error. How many of you? How many of you say that? Well, I mean, this is not modifying anything anyway. This is not a compiler error.
The important part is the keyword, const keyword. Input may also not change the variables.
Yeah, exactly. It is exactly the reason what you said. I mean, compiler doesn't have to go to the implementation of this getSense and see if it is modifying anything or not, okay? Compiler only sees, when it is compiling this line, compiler only sees this definition. This definition says that I am a non-const function, okay? I am a non-const function. If it's a non-const function, okay, if it's a non-const function, then I can't call this function, okay, because I am a const function. Doesn't matter what you do in getSense or in input, as long as it's not a const function, you can't call it.
If you optimize, if you use the optimize flag,
Yeah.
there will be any difference?
No. Well, no. Well, that's a very good question. I mean, if I had a smarter compiler, would it inspect the code, right? Would it inspect the code and would say that, no, well, this doesn't modify anything? No. Okay? The reason why it is no, remember, when I call a function in C or C++, I don't see its implementation at all. It might be in a library. I am going to link it later. Remember the linking? Linking links the functions later. So if getSense is a function that I don't have the source code, okay? If I receive this getSense from a vendor who implemented this function, I have no way of going into the code and checking if getSense modifies something, okay? Compiler only sees, okay? When compiler sees it, is there a getSense function somewhere? Okay, and okay, is there a getSense function somewhere? And we say yes, it is here. Okay, so the compiler says that it doesn't take any parameter, it returns an integer, then I am okay. I am going to call this function. It doesn't have to see the implementation. It doesn't see the implementation. Okay, that's why I need to put this const in here, otherwise it doesn't work. That's why the book keeps saying the same thing over and over again. Const is a all or nothing thing. You may not, once you start using const, okay, you should use it wherever it is usable. Okay, for half of my program I am going to use const. For half of them I am not going to use it. Doesn't work. If it is usable, okay, if it is applicable, then you are going to use const. Otherwise, your output cannot call your getSense. You will get an error message. Okay, good. Use of const, all or nothing thing. Okay. You apply this to everything, including your parameters, your const functions, and everything. And during your exams and or your homework grading, if you forgot your const, that's a big no-no. Okay, that's a big mistake. So you are going to lose lots of points. Const is important. Okay, you are taking this course to use const, and you understand it. Okay, even though you don't have to use it, you are taking this course to how to use const, or even though you don't have to use object-oriented programming, you use your C++ compiler. I have seen people, they are writing classes like this, and these are engineers, right? They say public. They don't have the private keyword in their dictionary, okay? They make everything public, all the functions, all the data, no const usage and everything, okay? And compiles and it runs. I mean, it becomes like a C program that uses the class keyword, and that's it. This is not a C++ or object-oriented code, okay? This is just a weird code that uses the C syntax, but it has some C++ keywords in it. Okay, so these are the things that we are trying to learn in this course. Okay, good. We talk about the inlines.
Can I make an analogy for this kind of stuff?
Sure, yeah. But say it louder so that everybody can. Those people, nobody's sleeping? Oh, okay. So
in CS 101 lecture, Mehmet Hoca says these kind of those software engineers doing this kind of stuff is like a member of European Union countries, but you live in Macedonia.
well, okay, that's a good analogy, but it's kind of a discriminatory analogy, but yeah. And we don't try to discriminate people and people. Yeah, well, yeah, that's kind of. I don't know. I mean, it is like what do I say? How do I say? You have a very expensive car. It can do the 300 kilometers per hour and that kind of stuff. You don't take your car to the track. You only use it on E5 under 90 or something like that. Maybe, I don't know. Maybe his analogy is better. I don't care about the analogy. The analogy is this: if you are writing in C++, use the object-oriented programming principles. That's what we're saying. And I am not going to. I mean, I get this question. I get this comment all the time. What is the difference? This one works and this one works. It compiles, you see. I mean, this always comes with the homeworks and exams. What is the difference? But I tried it. Both of them works, and both of them are fine. And if you don't know the difference between using const and non-const, then you didn't listen to me. Okay, inline functions. Remember, inline is a keyword. You may choose to inline your functions. And inline means that you are not going to, your compiler will not make a function call, okay, since, where is it? Yeah. Since this get rate or get sense, okay, is inlined, whenever you use them in your code, get sense, did I use it somewhere else just once? Okay, it looks like I did not use it at all. Maybe in my main. Yeah, well, I did not use it, but I could have said, okay, I could have said account one dot get sense. Okay, when I say this, there would be no function call for line number 61 because get sense is inlined. Okay, it is inlined. I have implemented it. I have implemented this function in my class definition. Okay, in my class definition. So function calls are definitely expensive. So if you like to get rid of this overhead of function calls, then inline your function. So there are two ways to inline your function. One is implementing it in the class definition. The other one is putting an inline keyword at the beginning of the, for example, I may choose to inline this one, output. Well, it is more than 10 lines long. Maybe I shouldn't inline this because longer the code, when you inline it, instead of calling that function, this whole, it is like whenever you call this output, this whole bunch of lines will be pasted by the compiler to the place where you are calling this output. Okay, so you are increasing the size of your produced code, and that will make your final code large. Okay, it's going to use lots of memory when you load it. That's not going to be good. So use it with caution. the rule is okay for very short functions only, not for the long functions, for very short functions only. And if you do that, it will increase your performance. But as I said yesterday, if you are optimizing your code with a -03 flag, this inlining is done automatically, and compiler chooses sometimes to inline your code, sometimes not inline your code, okay, depending on the situation, and that would be a solution. So why are we talking about the inlines now if the compilers can optimize for that? But that doesn't mean that you have the proper compiler for your platform all the time. G++ compiler is a very advanced compiler, and it is available for Linux and Windows. But if you are working on an embedded system, right, there is only a very simple C++ compiler. That compiler may not have any optimization flags because it's a primitive compiler, okay? So for that case, using inline is a good idea. So learn about it.
Can I ask a question?
Sure.
I think, as I understand, inline stuff was made by compiler at compile time, right?
Sure, yeah.
And so compiler can move body of function to class inside of class definition, so it shouldn't change size of output executable.
No, well, it changes. Remember what I said?
But it shouldn't duplicate.
Well, it does. See, this is inline, right? Output. Okay. I copied it, and if I inline this one, if I go to the main function, where is my main function? Main function, and where is output? Let me make this output. So the compiler doesn't make any calls here. Okay, it removes it, and it pastes all this code in this part.
Why? It is not cut and paste instead of copy and paste.
What is the difference?
If it cut and paste, size is not going to.
Okay. You are saying that you are calling this only once, but what happens if you call it 50 times? You are account 1 dot output, account 2 dot output, okay? This key output function is called maybe 50 times at 50 different places.
It copies for every object.
That's what we are saying.
Not only for class.
Okay, so it becomes, your code becomes large, and large code, maybe you might say, well, I mean, instead of 1 megabyte of executable, I'm going to have 2 megabytes of data executable. That might be okay, but large code is sometimes not good because your code will not fit into cache. If it doesn't fit into the cache, then your code will run slower, okay? So sometimes larger code means slower code too. Yeah.
Why class member functions defined multiple times for every object variable instead of just using pointers to point classes?
Who said it? They are defined multiple times.
You said before. Now, if you said before.
For each object, there is only data members in the memory.
You, what if I cut and paste instead of copy and paste? You said what if it call it 50 times?
Yeah.
You mean it pasted for every object,
not for. Well, you are not listening to me. So okay, this is account 2 output. Okay. After that, I did this. Okay, this is one calling of output, if I can make a copy of it. Okay.
Is it pasted into main or class?
You are not listening to me. What did I do? Okay, didn't I remove this line and paste it in this line? And I'm going to do the same thing for account 1 and account 3 and account 4 and even account 1, even if I do this. Okay, 5 different copies of the same function will be pasted at this location. So instead of I am seeing here, okay, 5 lines is going to be 50 lines. and the same repetition of the same code. Okay? Yes?
Since my members are private, if I inline setters, would that be a compiler error?
If you inline your private function,
No, I have private rates and
you have private what?
rate in there, member integer rate.
Rate, okay, huh?
And if I inline set rate, rate is private, so it needs a setter function to change it. So if I inline that, would that be a compiler error?
Well, this publicness and privateness are for ourselves, for the programmers, okay? Compiler may choose to do anything. It is not for the compilers. It is not for the... When you look at the produced assembly code out of your program, you will not see any public-private stuff, okay? Everything is gone. It is converted to regular assembly. And in fact, the first generation of C++ compilers, they were compilers that translated your code from C++ to C, okay? So basically, I mean, when we say set balance is a member function, compiler just produces a global assembly function for the set balance. And it says that it has two parameters. One is the object, the other one is the balance, okay? So these are all converted to global functions. So in the compiler's world of assembly programs, okay, on one side you have your C++ program, on the other side you have your assembly program, okay? In your assembly program, there is nothing about objects, there is nothing about public, there is nothing about private, there is nothing about const, okay? So it doesn't matter what you are inlining, it is a public or private. Compiler behaves the same way. As I said before, let's say I didn't write this class myself, okay? Let's say I didn't write this class myself, bank account, and I received this class from somebody else. They sent me this header file, okay? And of course, their libraries too. I can go in their header file, and I can take this out, private out. Now, as a customer, I can modify account dollars, account cents, and everything. Okay? The compiler would not care because the compiler sees this as a public part. Okay? Again, these are all for the programmers. It is not for the compiler. Okay?
Is line 22 is inline?
22?
Yeah. Not that one.
22?
No.
Well, the constructors are usually not inline, but
Which you said return something.
was it in the other one?
Yeah.
Yeah, well, yeah, sure.
But this is not in main, right?
This is in the class definition. What did we say? Inlining is done in two ways. Either you put an inline in the function implementation outside of the class, or you implement your function inside the class, and that's what makes it inline. So these are automatically inline. Okay? Inlining is for functions. It is not decided during the compilation time. This getSense function is inlined. Yes?
How does inlining make our code more efficient?
I am not hearing you at all.
How does inlining make our code more efficient for short body function?
Well, I mean, when you inline your code, you are not making any function calls, and function calls are expensive. Okay? What do you do with the function call? You send a parameter to it, okay? For example, if you inline the set balance, you don't have to make a call by value function call. You don't have to take a copy of this balance, okay? You don't have to do that kind of stuff. And you don't have to remember where you're going to return. Okay, that's the important thing. And when you branch from your regular position to some position in your memory, that's kind of bad for the cache usage. And you are going to see it why in your third year, I guess. That will be inefficient. Making function call is expensive. Okay.
Is inline functions in main is more, can you say, more inline than these kind of open parentheses?
We don't make inline decisions by looking at where the function is. It is get rate is inline. That's it. Okay.
But if I call it from any object from main,
Get rate is inline. That's it.
I need to call it from.
Get rate is inline. Okay. The decision is made. Okay. It is inline. Wherever you call this get rate, it is inline. Okay. Let me move on. Inline member function we called it. Okay. So if you use it properly, it is efficient. But it is if the function is too long, and if the function is called in many different places in your code, then it is less efficient. So we talked about this. These are inlined. And in fact, I showed you that's right. Okay, good. So let me move on to other topic. C++ has a new member initializer syntax. This was available in some other languages, and they made it possible for C++ 11 too. If you like, okay, you may initialize your member variables in the class definition like this. Okay. I have two private x and y. These are their default values. And as you see in my coordinate, this is the coordinate, okay? In my coordinate constructor, I did not initialize x and y because they are already initialized. This was available in Java, but not in C++. Now it is available in C++, but again, it is for C++ 11. Okay? So this is a new feature of C++ 11. Member initializers. Good, we can use them wherever we want. Okay, that's one thing. The other thing is, again, another new thing for the C++ 11, constructor delegation. Okay? Let's say I have two constructors for the coordinate. Remember this coordinate class, simple class. I am representing a two-dimensional coordinate. Okay? This is the first coordinate constructor. It just takes x and y values as parameters, and it uses the member initialization syntax to initialize this x and y, right? I did that. My no parameter constructor says that, okay, I am going to initialize x and y to 99, both of them. So instead of saying the same thing like this, x 99, comma y 99, we say that I am going to delegate, okay, the constructor overload that takes two parameters, okay, and I'm going to call it. This is called constructor delegation. So one constructor is delegating the other one. It is calling the other one. Okay? So things are simpler now. Why? Because, I mean, whatever I am doing inside this coordinate, I know that it will be done for this no parameter constructor. And this is available in C++ 11. Okay? Good. By the way, yesterday I think I put the style file for the styling rules for the Google's C++ developers. I think C++ is the #1 language for the Google developers. They do their stuff in C++. And read this. Yeah, it is here in my, yeah. Well, read this style. I am not saying that you should apply this style or anything like that, but it talks about stuff and it tells you why one thing is good and why the other things are bad. For example, I remember they talked about inlines. Where are my inline functions? Yeah, okay. So Google says that to their employees, define functions inline only when they are small, say 10 lines or fewer, okay? Up to 10 lines, you may inline them. Okay, advantage of inlining a function is inlining a function can generate a more efficient object code as long as the inline function is small. Feel free to inline accessors and mutators, getters and setters, and other short performance critical functions. So the Google says it is okay. How about the negative size? Overuse of inlining can actually make programs slower. Depending on a function size inlining, it can cause the code size to increase or decrease, okay? Inlining a very small accessor function will usually decrease the code size because you are not calling anything and the function definitions are gone, okay? So they give you this kind of stuff. Okay.
Aşamasından ziyade memori fazla kullanımı olmaz mı?
Are you talking in Turkish?
Sorry. Isn't there should be some memory overuse other than get slow?
Well, it says depending on, okay, can make programs slower. Inlining can cause the code size to increase or decrease. Okay, so if you use your inlining properly, your code will both will get faster and it will get smaller. Okay, if you use properly. If you use it the other way, in a not proper way, your code size will increase and it will get okay. So what else? For example, read about the const keyword. Okay, do I have it? Const. Let me try to find it. Just a minute. Oh, 200 const. Use of const. Yeah. Okay. Use const whenever it makes sense. Okay. Pros easier for people to understand how variables are being used. Allows the compiler to do better type checking and conceivably generate better code. Helps people convince themselves of program's correctness because of that, because they know that I'm going to modify anything.
What is const exp?
I didn't talk about it yet. We'll talk, okay? So somebody had a question, yes?
Does it decrease the efficiency to have too much inline functions?
If you have too many inline functions, well, remember what we said. If you call your inline function in many different places, every time you call it, okay, its code will be inserted at the calling position, okay? Say I have 100 different places that I am calling this output function. Remember, output function is 10 lines. Every time I call it, my code will increase by 10 lines, okay? So that's the rule. So you make your decision that way. That's what Google says too. Okay, so you read the style file, and I think they have defined their style guides for the other languages too. For Python, there is a style guide. You know, Python, you don't have any variables, right? You have variables, but you don't declare them, okay? You don't say I have an integer or double or anything like that. So that's why we say this is very flexible, okay? You start using, when you say a gets the value of 7, compile the interpreter immediately determines that a should be an integer, right? So it makes a declaration automatically for you. But Google says that don't do this. In a command line, type a is an integer, okay? If you don't do that, they will not accept your code, okay? It will be rejected by somebody, not by the compiler, okay? Not by the machine. It will be rejected by your code reviewer. It says that you didn't declare a as an integer, and you might say, in Python there are no integer declarations. I mean, this is a not very type sensitive language, right? I mean, it just you use it, it automatically determines it. No, it is against our style. It is against our discipline. You have to declare your variables in a command line. So it is not for the compiler or interpreter. It is for ourselves. Okay. So read these, and I mean, I am not saying that you should follow these stuff. Okay, you should. I am not saying that you should follow this stuff. It is important to understand why we are doing that. Okay, why there is this decision. For example, increment and decrement, right? Pre-increment and pre-decrement, plus plus I, or post-increment and post-decrement. Okay, the decision is use prefix increment decrement unless the code needs the results of the postfix. So it says that prefer plus plus I to I plus plus, right? Why? Because why? I think we talked about this. I plus plus is better than, okay, plus plus I is better than I plus plus. Why? Yeah.
Because in post increment or decrement, you have to copy it first,
Yeah.
and then return.
Exactly. You have to take a copy of it. Okay. You have to take a copy of this I, increment I, return the original value, right? But this one directly increments the I and returns it. That's why. So postfix increment decrement expression. Okay, this can result in code that is more compact but harder to read, and prefix form is generally more readable and can be made more efficient because it doesn't need to make a copy of the value and etc. So we talked about this. That's why I'm saying that, okay, that's why I'm saying that read this, okay? Read this for C, Python, C++, and try to understand why we are choosing both. I mean, style means that, okay, anything, look at this one. Where was this? There was, where is it? I have seen function definitions. Anything in this file, they are all compiler-wise okay. They are syntactically okay, okay? There is not a single line that produces error message in this style file, but it says that this is wrong, this is correct, this is wrong, this is correct, right? So why are they wrong? Because they don't fit our styling. Okay, I was looking at a function definition somewhere. Bad, double bad. Not one, not one. I couldn't find it. I couldn't find it. It was talking about if statements, how to write if statements. There should be some space between the parentheses and the if statement, but there should not be any space between the parentheses and the expression itself and etc. But I couldn't find it. All of them are okay. Do you guys see the if statements, header files, scoping, classes, functions, naming, comments, formatting, conditionals, maybe? Conditionals, yeah. Doubly bad, yeah, okay. See, this is bad because you didn't put a space in here. This is bad because you put a space in there. This is bad because you didn't put a space in, okay? You understand what I mean? They are all compilable. What is wrong with each of them? But their style is like that. So they are not crazy. Maybe they are crazy, I don't know. But I mean, if this job requires to be crazy, then we are going to go crazy. And these are the stuff that you have to follow. Anyways, okay, let's go back. And I am still trying. This is the 4th week of the semester. I am still trying to make sense for you why you are taking this course. I mean, I could have done everything in C, but I am taking this course to learn C++, and it looks like I could have done all of these stuff in C, but the experience tells us that, okay, 50 years of software engineering experience, if you follow these rules and if you follow those styling rules, your final code turned out to be better than before. Okay, so another important topic. Well, maybe we don't use static members much. Maybe it is not frequently suggested to be used in your classes, but they are important to understand what a class means, what a object means, and we are going to look at this static members. Remember what I said before when I say day of year, D1, D2. Whenever I say this in my memory, okay, this is D1, that is day and month data members, and this is D2, that is day and month members. They have their own space for each object for day and month. We looked at that, right? So every time I make a new declaration of this day of year class, I get my instances and their variables are inside them. Static members, okay, static members are members of a class. Let's talk about static data members. They are data members of the class, but you don't repeat these static members for each object. If you say, I have a static integer for this class day of year, or there is only a single integer available for all the objects, okay? So all the objects share the same integer. They don't have their own copies. All the objects of class share one copy, okay? That's called a static data member. And you indicate this by using the static keyword at the beginning of the definition. Let's look at this. Let's look at this code. Okay, I'm going to keep this. Okay, box is a very simple class. Public box, private section. Box has it's a rectangular box. It has a length, breadth, and height. Okay, so it is three-dimensional shape. These are our regular data members. So when I declare a box, okay, when I say box, okay, B1, box 1, 3, 3, 1, 2, 1.5, okay, this one will be 3.3, 1.2, and 1.5. You understand it, right? So when I do that, okay, box 1 will be this and this and that, right? And box 2 will be this and this and this. As you see, I did not put this object count inside my objects. Why? Because this object count is declared as static, okay? That object count is a private data member of class box, but it is not non-static, okay? It's a static data member, and it's like a global variable, and it is kept in somewhere in the memory, and its name is box scope resolution operator object count, okay? And it is stored somewhere in the memory. If any of these objects wants to, okay, access this object count, they access the same place here, okay? So it's kind of maybe a communication mechanism between the objects of the same class. It is called static. So you might think static variables as like globals. There is only one copy. It's a global, but it is only accessible within this class because it's a private. You cannot access box object count from outside the class. It is only accessible from inside the class. It kind of behaves like a global, but it's a limited global. That's why it is not as bad as globals. Okay, it's not as bad as globals. It has a constrained scope. Its scope is only within the class, so nobody can modify it. Nobody can access it other than the class functions. Let's see the implementations. Okay, let's see the constructor. Constructor says that these are my default arguments. Somebody called the constructor. I am going to do this assignment first, then this assignment, then this assignment. Okay, then every time my constructor is called, I am going to increment the object count. What does it do? I kind of count the number of boxes constructed, right? So this one is incremented once every time the constructor is called. So the My constructor is counting the number of objects that I have constructed so far, right?
But we didn't initialize object counts.
Okay, so you initialize your object count. He asked me, Abdurrahman asked me, where do we initialize this object count? You initialize your object count, box object count, outside of your class, like a global variable. You might say that, well, I mean, if I am outside of the class, how can I access the private data member? This is a special notation for your static data members. You need to initialize your static data members, okay, somewhere, and it is the place to initialize it. Question for you. How come we don't initialize our static data members in the constructor? I initialize everything in the constructor. The way you raise your hand, you know the answer. I don't like those students who know the answers all the time. I like those guys. I mean, they sleep. You have any guesses? Why aren't we initializing our static data member like the others in my constructor? Yeah.
It doesn't make any sense to use static thing with a constructor.
Why?
Because we mainly use static things like counting how many members do we have or
Yeah, well, be more clear. I mean, why don't I make this object count 0? Object count is 0. Why don't I say that? I am initializing it, right? If I do that every time I make a new object, right? If I do that every time I make a new object, object count becomes 0. So what is the purpose of doing it then? So object count has to be initialized exactly once for the whole duration of the program. Not every time an object is constructed, okay? Object count has to be 0. And it doesn't matter if I have any objects of that class, doesn't matter. It always has to be initialized as soon as the program starts. That's why I initialize it like a global. See, this is like a global, right? If you didn't see this box, this part, okay, it looks like a global, okay? But of course it is not a global. It is inside the box class. Its name is object count, and I am initializing it with 0. Before my main starts running, my object count became 0. And when I make this object, okay, when I make this object box1, it made that object, and my at the beginning, my object count is 0, okay, and my main starts running. I make an object. My object says that okay, I am this. I get the space in my memory, but at the end of the constructor, I will make this one, and I am going to make another object. This time it will be this object, and my object count will be 2. Okay, and I have the third function in this case. It says get count. It's like a getter, and it returns the object count. But see, it's a static function. So what would be the difference between static functions and the normal non-static functions? Okay, static functions, they are constrained. They can only work with static data members. Okay, they can only work with static data members. This get count cannot talk about length, breadth, or height because it's a static function.
Even can't read.
Say it again.
Even can't read one of.
No. Can't. It doesn't have an access to. Okay, and there is a good reason for it. Why? Because if a function is static, okay, if a function is static, then I can call that function without needing any objects. So this is what I do. See this one? I am calling get count not on a box1 or box2, but I am calling it on box. Box is a class name. It is not an object name. This is the first time we are seeing such a thing. It looks weird. Well, I mean, if this doesn't look weird, then you are not studying at all. I mean, when you look at this line, and if you are not get surprised, Okay? If you don't feel dizzy by looking at this line, you are not studying at all. You are not in a good position in this course. We have never called a function like this. To call a function, you need an object, right? Well, objects are here. Maybe I could have called I could have called box1 dot volume, box2 dot volume, but now I am saying box resolution get count. It means what? Give me this number 2, and I can do that because to call this get count, I don't need any of these objects, right? I don't need any of those objects. Yes.
We use STD resolution C in or C out.
It is the same operator, yeah.
So C in and C out also static.
No. That STD in that case is a namespace. It is not a class. Yeah.
Can we implement object count in the definition of class but not in the function?
In the definition, object count, yeah, what? Can you access it? I mean, box resolution object count. Is that what you are saying?
For example,
Without calling the function.
in the private section,
In the private section.
let's say object count plus plus. So
Well, I mean, you can't. In this case, you don't have a function in here. I mean, you are saying that should I write a function?
no, just say object plus plus.
You cannot execute anything in private data members. I mean, how are you going to say object count plus plus here?
Every time we instantiate an object, it does the thing in there, and so
You are saying that I am going to write plus plus here? Is that what you are saying?
or at the next line.
Well, this is definitely not allo, then it doesn't make any sense. I mean, what does it mean? I mean, you put a plus plus. When am I going to call this? Only once or every time? Or I don't know. So definitely there is no notation like that. If you are going to modify this object count, okay, since this is private, you need to be either in the constructor or in volume or in get count.
But I can do things like length equals 3, for example.
You don't say length equals 3. You say length assignment 3. There is nothing like equal. Okay. Yeah. Well. Oh, you say. Oh, you are saying that I can initialize it like this. Why don't I initialize it like that? Is that what you are saying?
Then put an object count plus plus, so it should be.
Well, if you are asking this, yes, this is possible. Like this is possible in C++11. Yeah. I mean, if you are asking this is fine, but definitely no. This is definitely no. Okay. Okay, so I think you are thinking like every time I make a new object, increment this, but different constructors may choose to do different stuff for object count, right? Maybe some of them are incrementing, maybe some of them are decreasing it, etc. So you may not know it, but anyway, maybe we shouldn't talk about it like that because it's not our decision. Plus plus definitely not good thing, okay? Not good thing. By the way, I mean, remember this is only available in C++11. Like this one. So we prefer initializing our object counts or the statics like this, like a global, so that we are compatible with older versions of C++. I think I'm way out of my time. Let's take some break, 10 minutes. When we come back, we will continue on this.
Statik değişkenlere şeyden erişemeyiz değil mi?
Yoklamacılar gelmeyin buraya artık ya. Yoklamacı.
Hocam ben şey soracağım.
Saatleri karıştırmışım da.
Tamam iyi yok sayıldın.
Statik
Zaten
fonksiyonlar
soru falan da sormadın.
Hocam elimi kaldırdım görmediniz mi?
50 tane soru sorsan da yok yazıldın. Yok demek orada ismin yok demek. Gireceksin.
Şurada otur.
şey soracağım. Statik fonksiyonlar
Tekrar otur kimse almasın.
statik fonksiyonlar C'de de mi öyle çalışıyor? Sadece statik
C'deki statiğin manası çok farklı. O nedenle biz artık hoşlanmıyoruz. Yani biz fonksiyonun statik olması demek.
sadece o failde kullanılabiliyor.
Evet.
Bir şey.
Evet.
C++
Buradaki
öyle
manası çok farklı. Ama bunlar global fonksiyon değil. Bunlar Senin şey
Member
fonksiyonları, member fonksiyonları. O nedenle statiğe bak şöyle yazarız. Şu statik fonksiyon ya bu. Bunu dışarıda implement edeceksin ya. Box, binary scope resolution, get count, onun başına statik koymayız. Başına statik koyduğumuz zaman C'nin statiği manasına geliyor.
Sadece o failde.
Evet. Koymayız adam. O da hoşuna gitmiyor şeyin.
Evet.
Compiler niye member fonksiyonu nasıl sadece bu fayda geçerli olur ya falan diyorlar.
Evet. Anladım hocam, teşekkür ederim.
Tamam, nereden biliyorsun sen statiğin şey olduğunu, o fayda geçerli olduğunu?
Hocam 42'de öyle yapıyorduk.
Nerede?
Ekol 42'de öğrenmiştim.
Nerede öğrendiniz?
Ekol 42.
Ekol 42 ne?
Hocam şey var ya, bilişim mühendisliğinde yazılım okulu var bir tane.
Öyle mi? Kim
Aynen.
öğretti onu?
Hocam orada proje yaparken
Kendin mi öğrendin, birisi mi öğretti?
birisi öğretti.
Kim öğretti?
Oradaki öğrenciler hocam. Sorarak.
Buradaki öğrenciler sonra ben buraymış diye merak ettim.
Burası boş.
Kanka niye? Kanka yapma böyle şey. Alma kendini zarar. Ekmeğine zarar. Onu triple.
Oha ya. Yine mi?
Yine.
Arkada mı? C++'daki statikle Java'daki sanki bir var değil mi? Ekstradan anlatmış geçeneği. Java'da da var. Ben onu cümleyle biliyorum. Böyle bu durumda öğrendim mesela. Mesela bir şey söylüyorum. Bayağı bir şekilde program çalışıyor. Java'nın yanında başlangıçta
Ben biliyorum. Normalde ben böyle çok alışık değilim onun için. Elimde karakter gol yemezsin. Ona ağırlık var.
Buraya yükleniyor. Yükleniyor. Oğlum stres yapalım. Nereye yükleniyor? Buralara yükleniyor. Oğlum kas olması gerekiyor muydu? Ya dizin niye ağrıyor oğlum? Dizin kas mı?
Görür. Kesin görür yani. Ne yapsam? YouTube'da izlediğimi bile hatırlıyorum yani.
Sıfırdan korkmuyor öğrenci. 2 hafta, 3 haftada. 4 hafta proje başlıyor. 6 haftada proje. Öyle tabii çok bir şey değil. Ama Firebase falan SQL Python Django yönetemezsin şimdi. Spring'i yönetemezsin. 2 hafta bir şey değil. 2 ay, 3 ay. Temel
Demo yapacağım diyorum.
demo yapacağım diyorsa işte proje olacak. Ya proje değil, çok küçük bir şey.
Can we initialize hocam bu şeyleri tek satırda initialize edebiliyor muyuz? Provide class'ın içinde, provide section'ın içinde double length ve height ayrı ayrı yazmak yerine
Her birini ayrı ayrı double yazman lazım.
Ben kız olayım diye
çalışmıyor.
Compile olmaz.
Bak pardon.
Ben size o zaman bu öğreteyim.
Okay, let's start. Where is everybody? Where are they? Okay, so this program, this is our definition. Okay, box. We looked at it, and we have a static function. This static function is a special one. Why? Because I can call the static function without needing any objects. See, I did not use any object name to call the static function. As the name of the static implies, okay, it is always there, okay? This object count is always there in my memory, even before the main start. That's why we say that they look like, very much like a global, okay? Their life duration is like globals, but their scope is different. Their scope is only the class scope. Okay, so this is important. Well, it is possible to say things like cout box 1 dot get count. Okay, it is possible to say this. I am calling this get count on this object like a regular non-static function, but we don't prefer using this. Okay, it's not a compiler error. Okay, maybe I shouldn't do a red cross, maybe I should do a black cross. This is not a compiler, it is okay, but we prefer calling them using this notation, class name on the name of the static function. What did we say? Static functions, they don't have access to length, breadth, and height, because those are non-static data members. They can't. Why? Because remember this one? When I call box get count here, there are no objects at all. I mean, which length I am talking about, okay? And the other thing is that which object's length I am talking about. So these static functions, they cannot reach the non-static data members or non-static for the same case. I can't call, in this case, okay, I can't write, okay, cout volume, okay? I can't call this. Why? Because volume needs length, breadth, and height, okay? Well, I mean, if I call volume, then what's going to happen? That's why we say that static functions cannot call non-static functions, or they can't access any of the non-static data members. It's like const, right? Remember the const functions, they cannot call non-const functions, right? So statics cannot call non-static functions. Okay, so this example is not in the book. I think I got this from somewhere off the web. I don't remember. It's not mine. Book has another example. The book's example is not that nice. It is a little bit complicated. It is not like complicated in terms of C++. It's not a very well constructed program, but I'm going to look at it anyway. Okay, did everybody sign their names online? Sign your names. No, I think we have 10 more minutes. Sign your names. No, it is, we start at 9:40, right? Do we start at 9:40? 9:40 to 9:55 maybe. Okay. So let's look at this one. This one has a class server. Server is like a server from a restaurant. Okay. When I go to a restaurant, okay, somebody has to serve me. So I am going to have a number of servers maybe, and each server has a name to it, like a character. Name would be A, B, C, and etc. Okay. So it looks like the constructor is going to take the letter name of the server. So I'm going to build maybe 3 servers at the beginning. Okay. Why don't I show you the final output of it? Let's look at the final output. When the program starts, okay, how many in your group? I say 3. Okay, I went to the restaurant and somebody's asking me, how many are you? We are 3 people, okay? So if you are 3 people, server A is going to serve people number 1. Server B is going to serve people number 2. But it looks like I have only 2 servers. So one is waiting. Then a number of other people come in and ask the same question, how many in your group? Okay, 2. Now your IDs are 4 and 5. I have total of 5 customers now. Server A is serving A and B, and 2 more people. Now server A is serving this 3, okay, this one. Server B is serving 4, and in the final loop, nobody came, and then how many people left? Only number 5 is left. So server A is now serving number 5. It's like this picture. It is like this picture. I have only 2 servers, okay? 3 people came in, and I said that this one is going to be served by this one. This one is going to be served by this one. And after that, 2 more people come, okay, 4 and 5. Then I said in the second iteration, 3 will be served by A, and 4 will be served by B. Then no people came, and finally I said 5 will be served by A. Something like that, okay? So A and B will be my servers. There will be two server objects, but both of them has to remember whose turn is this now. At the beginning, the turn number is 1, okay? And if I am serving 2 people, then the turn number is 3. So both of them has to remember the same term, okay? And both of them has to remember who did we serve last. And this static boolean is, are we open? Okay, 3 statics, okay? That's why I initialize them. At the beginning, turn is 0, okay? Nobody came in yet. And last served is 0, I didn't serve anybody. My restaurant is business open for business, okay? So that's what I did. Let's see the main function. I make 2 servers. So this one, let's look at the server constructor. Server constructor is very, very simple. I just assign this letter name to name. That's it, okay? So server constructor say that S1 will be named A and S2 will be named B. And I have a loop here. And this loop will continue until server still open becomes false, okay? And still open is a static function, okay? That's why I am calling it with server. I keep calling it, are you open, are you open? If I am open, then I'm going to take new customers and etc. And this one, get turn, will give me the turn. Whose turn is it now? Serve one is a non-static one. Okay, serve one is a non-static one. I am asking one of the servers to serve one of the customers, customer number 1, 2, 3, etc. Okay, good. So how many in your group? I get the number. Okay, now I am saying that from count 0 to number, I am saying that, okay, you are going to, I am going to give you some turn numbers, okay? It's like you went to a bank and you get your turn numbers. So you get the turns. At the beginning, the turn number is 1, 2, 3, it's going to like that. But this one still remembers what was the last number that I gave as a turn, okay? So server get turn will give me those numbers. Remember the final output, okay? When you say how many in your group, okay, your turns are 1, 2, 3. How many in your group? Your turns are 4, 5. And in this one, how many in your group? It is 0. That's why I am not giving any turn numbers anymore. Okay, so this one will give turn numbers. Then I am going to ask S1 to serve one of the customers and S2 to serve another one. So S1 will go to the queue and pick one customer and modify the queue so that the last served will be incremented by 1. And so S2 is going to do the same thing. And I'm going to continue until still open becomes false. Still open becomes false when there are no customers left. Okay, so this one and this one, these are static functions. That's why I call them on the server. And S1 and S2 are objects. Serve1 is a non-static function. Okay, so this is basically the whole main function. Let's look at the function definitions. Constructor, okay, don't forget about this, okay, these are important. These are initializing your static data is important. The constructors are not good places to initialize them. Constructors are good for initializing your member data for each object. But if you are going to initialize something for the whole class, remember how I talked about the classes? Remember when I say day of year is like a set, okay? I have D1, I have D2, D3, etc. Many objects of it, okay? So these static data members, okay, are accessible for each of those and they are the same. So I kind of keep them separated. This is turn, this is serve, and etc. And each of them can access this data. Okay, even if I don't have any members of this set, this static data exists and they are initialized. at the global level. That's why we initialize them at the global level. That's why we initialize them even before the main starts. Okay, so server initializes only the letter name. Get turn, it just increments the turn and returns it. Remember turn, it gives you a turn number. And still open returns just now open. Okay, remember, just note that I don't put a static keyword at the beginning here. Get turn is a static, still open is a static, and I think I have two static functions. Yeah, these are two static functions, but I don't say them they are static in the global level, not in here, 16, 17, 18, not in here, okay? Because the meaning of static for this kind of case is different for C, and I'm not going to talk about it. If I put a static at the beginning of this function, compiler would get confused, okay? So we don't put static keyword at the beginning of the static function definitions outside of the class. Okay, so increment turn by 1 and return it. Still open just returns it. Let's look at this serve1. Serve1 says that if the restaurant is open, if the last served is less than turn, how many people do I have in my queue? 5. Last serve is 2, so it is less than, maybe I should serve the last served, the current turn, increment it, and I am saying that I am serving this person now. That's the if statement. After doing that, okay, if last served is greater than or equal to turn, then I am making this now open false. This one here is a static data member, okay, and last served is a static data member, turn is a static data member. These three are all static data members. Okay, it is better to write, instead of just turn, it is better to write server turn, so that everybody who reads this code can understand that the turn is a really static data member. You don't have to write it because you are a member of the class and you are accessing your static private static data members. Yeah, it is okay, but better thing would be write it this way explicitly. Yes.
You can't use regular functions in static functions, right?
You can't call them, okay? You can't call inside a, okay? What is my regular function here? It is serve1, right? No, you cannot call serve1 from the still open because still open is a static.
How about the opposite one? I mean, can we call
Sure, the opposite is sure possible. Why not? You may call. Well, that's what I'm saying, right? Well, maybe I can say, yeah, I can say instead of server turn, maybe I can say get turn. Get turn, maybe. Yes, you can. It's like calling a constant function from a non-constant function. Opposite is not true, right? The other way is possible. Okay? Statics, as I said before, statics are not in C. Maybe they have covered it. In C, let's say I have a function void like that. You may have local integers I, and you can have a static local integer. Its initial value is int k0. Did you see this? Did they cover it? Did they cover it?
Yeah.
No.
Yeah.
Yes, they did. Only you heard it? Nobody else other than you? Okay. So it means what? It means that this k is a static local variable. It is like a global. It never dies. Its initial value is 0. But every time I call this function f, okay, it will be incremented by 1. So every time I call this function f, it will be first 1, then 2, then 3, then 4, and etc. Okay, so it never dies. And this is the initial value for the whole program, not the initial value for each function call. Okay, so this is our static local variable. Again, it is like a global variable, but only its scope is this much. Its scope is this much. Other than this function, I can't see it. Okay, so our static data members are like that too. Okay, they are only for that class. They have to be initialized somewhere. Okay, and they never die, even if I don't have any object of that class. Okay, usually we don't like statics in C. Okay, they say that don't use static data members like that, because if I mean, nowadays all the computers, including the cell phones, they have more than one core, right? They are running more than one thread. If I am calling this function 2 times at the same time, they interfere with each other. Okay, one of them modifies this k, the other one accesses it, and it causes some race issues. Okay, we call them race problems, racing issues. So we don't prefer statics, and usually people will tell you don't use statics. So why did I cover statics? I covered it because it lets me talk about, again, what is a data member, what should be a common thing for each object, and if I like to do it one common object for the whole class, how should I access it, and etc. So that's a good topic to know. And I am not sure what Google says about the static. Let me see what it says. Usually it says don't use them much. Static members, non-members, static member. Yeah, let's static and global variables. Let's go to static. Sometimes it's used to define a function not bound to a class instance. Such a function can be either static member, non-member. Okay, if you define a non-member function that is only needed in inter-usage, okay, should not. Non-member function should not depend on external variables and should nearly always exist in namespace. Do not create classes only to group static members. It doesn't say anything about static member and okay. Do not use class simply to group static members. Static methods of a class should generally be closely related instances. No, it is okay. Causes may make more sense as a member of a new class, especially if the class if they access external resources or have significant dependencies. Okay, instead of making them static, maybe make them non-static and put them in another class and use that class's data members as like globals, it says. Okay, it didn't say many bad things about it. Okay, so by the way, static functions are like globals, right? Global functions, right? Yes.
Can you open a function?
What function?
F function for refer to you.
F function?
Yes, you declare a static function, static mem variable. Okay.
You mean the function that I wrote?
Yes.
Where did I write it? Where is it? Where did I write it? Yeah, okay.
For example, we call a function in main 2 times. First time it gone and work. K increase. After it return main. Second time it again go a function. K if is K be 0?
No, of course not. But that's what I said. This time will be executed only once for the whole duration of the program, not for function. Okay? So this is like a global, as I said. It is initialized only once. It is initialized only once. And that's before the f starts. When you call this function f, every time k will be incremented by 1, and it will remember its the previous value. As I said, k is like a global. It's almost the same thing for the function, static function members. They are like globals, but you have limited access to them. You can access them only through the class. Okay, what was I was saying that, remember that these static functions are like global functions, right? I mean, I can call them from anywhere I like. I don't need any objects, and they don't need any data actually. They don't need any data to work on. Their data is already in their position.
Static member functions only from classes functions, right? Not as not like global.
Of course not. Well, okay, like this. I am calling this get count like a global function, right? From the main, from any other scope. Okay, and this is how you should call it. What did I say? You may call this box one get count from this box one dot get count, but don't do that. We don't prefer it. Okay, if you are going to call a static function, call it like that. Call it through the class name, so that the reader can know that it's a static function. Okay. Yes.
If I have to write uses functions, and which one is better, like creating a class called uses and making static functions, or just writing global functions?
We don't like global functions in C++. Okay, static, yeah.
Uses class is better?
In Java, there are no global functions. If there are no global functions, how do they have the trigonometric functions like cosine or sine? Okay, so they have a class named math. There is a math class. Okay, inside that math class, there are many static functions like those. Okay, so this is how you handle the need for a global function. Okay, so don't write global functions, do it like that. Okay, and if you don't have access to the math class, then none of those functions are available for you. So you are kind of restricting yourself to a class, and that's a good thing. Okay, but in C, C++, of course, we have global functions such as sine function or the cosine function or the square root. We don't put them in a math class as a static. Okay, good. Let me move on. After the statics, we are going to talk about nested and local classes. You may nest your classes like this. Okay, I have an outside class. It has a private int a. Okay, remember, if I didn't mention anything by default, this one becomes private. In my public section, I have another class definition. So this one class is defined inside another class, and it is defined as a public class. What does that mean? It means that I can do stuff like this. Okay, after this line, I can say outside O1 an object, right? O1 is an outside object. How about if I like to make an object of this nested? So I would say outside nested. This is my class name, N1. N1 is of type nested. Nested is not a higher level class name, global level class name. It is inside this class outside. Without the class outside, nested would not exist. Okay, I need it. If you like, if nested is definitely part of this class outside, okay, it is not meaningful to have this class nested without the class outside, then put it inside this class outside. Okay, then after that, I can do stuff like n1.f. Okay, of course, if I have statics in it, I need to initialize them. This is how you initialize it. In a class outside, there is a nested class. It has a static data member x, and I'm initializing it with 5. And there is a function f inside nested, which is inside outside. It just returns 0. And if you don't like to write very long sentences like these, then you just make a type def. I am going to call nested outNest from now on. Okay, outNest is a type definition. I'm going to access them using this notation. Okay, so it is possible to have nested and local classes. Nested is a local class of outside, and there is a, it's not like nested loops, right?
Can I ask the question? Why we instead of this don't make nested is another class and call its object inside class outside? Why we should make it like this? It's more complete.
I did not understand at all what you are. Why, are you asking me why do I make it a inner class, local class, instead of making it a separate class, nested?
And calling it from outside.
Well, you could, but as I said, I mean, sometimes we say that nested doesn't mean anything outside of outside class, right? It should be part of it, okay? So I'm going to keep it inside to show the dependency.
Why we choose this kind of?
You mean give me an example or something like, I mean, if I put this class nested outside of this class outside, maybe they might use it without using outside, and that's not the intention. It is supposed to be used by outside. Doesn't make sense to.
Doesn't make it more dependence, which is not good.
Yeah, well, we don't like it, but sometimes, I mean, if you keep writing very, very independent classes, set of classes, they don't have anything to do with each other, then there is no program, right?
But they would call each other's objects.
There is nothing, there is no such thing like calling an object. You don't call them, you make objects, okay? Sometimes we need this, okay? I cannot give you an example. For example, for a, let's say for a person class, there is a nested day of year class or date class inside it. This is not a very good example, but, and you are saying that for a person, I am going to have its birth date, and it is marriage date, and it's the graduation date, and I need objects of this one for that person. That's why I'm making this date class and inner class of this person class, and I'm not going to use this date class anywhere else. Okay, it is specific for this person class. Then I made it an nested one.
Can nested?
By the way, I mean, you may have the same named classes within the other classes. So nested could be another name for another class's nested class. Okay, so to keep using the same name for different classes. Yeah.
Can nested use the member function and variables of outside class?
Well, if there is an yes, if there, since this is part of it, yeah. This function f, if it has an object of outside.
So it is kind of inheritance.
Well, it is not exactly. In the inheritance, there is a is-a relationship. In this case, it is not an is-a relationship. It's more like composition, maybe. It's not exactly composition, but. By the way, this was at the end of the chapter. We don't use this kind of a structure often, but it is possible. What does Google say about the nested classes? Okay. Nested. It doesn't have inner classes, maybe. Inner classes. Local classes. Local, I don't have it. I don't have any other names for it. Do you guys, let me go to the beginning and there is an index. Scoping classes, implicit, construct, structs versus classes, inheritance, access control, declaration order. Inner classes, local classes. I couldn't find it. I am sure they are saying something, but it is not that common. Okay, at the end of this chapter, we have vectors. We already talked about it. By the way, do I have anything? This is 7.5. Let me open the other one. 7.6 is, I guess, this server thing. How about the 7, 7? 7, 7 is a vector. Let's talk about this one, yeah. So we already know how to use vectors. You are going to use vectors in your homework. It's an integer vector. It's like an integer array. But it is more than integer array, of course, because it does many things that easily, very conveniently for us. I have an integer vector. Its initial size is 0. It is initialized. I don't say that it is not initialized. Its initial size is 0. It doesn't have anything in it. Okay. With a while loop, I get many non-negative integers, and I push them at the end of this vector one by one. And every time I print how many elements I have inside this vector. So it's going to be 1, 2, 3, 4, 5, etc. Okay? So this loop will continue until I enter a negative integer. Then I print them out like this. So pushback works very nicely. Okay? Can I run this and execute it? Compile now, yes. It is going to run. Yes, maybe is it running? Yeah, it is running. Okay, place a negative at the end. 45, this one. Every time I add something, it is adding to the end. Okay, let's do -3. I added 8 numbers, and now it is giving me all those 8 numbers back. Okay, so this is how it works. By the way, we use range-based for loops a lot. Okay, I say auto I v, right? Okay, then see, I just say I. Maybe I need that because I is for indexes, right? I don't say I, but maybe it's an integer. What should I say? Let's say I, A. Okay, compile it. Okay, it will compile and run. It is exactly the same thing. Okay, so we prefer line 23 over line 22. Why? Because this one is more efficient. Every time I run this, I call this v.size, okay, and calling that is expensive, and I am doing this incrementation, and I am doing other stuff, and etc. This one does all that for me, and it is that in an automated way, in a optimized way. Okay, so try to use range for loop as much as possible.
How it does it?
Well, I see. I'm calling this v.size all the time.
Yes, but I'm asking how a comma a
Column.
long read
Yeah.
does this loop section.
That's the definition of the range
You say
base.
it's more efficient. I'm asking how it's more efficient. How it's.
But that's what I'm saying. Every time I'm calling v.size for every loop iteration, right? This one doesn't do it.
How does it stop?
You mean how does it know that it knows the size from the beginning, and it doesn't call the size function all the time? Okay, it knows its private data and etc. Yeah.
I can assign v.size to int variable, and I can use it. If I use it, it's same efficient or.
Well, previous I was using that assignment. That was one of the inefficiencies of using that kind of loop. Now, this A is directly. Oh, wow, you are saying that this is making an assignment. Well, you could. You mean this, right?
No.
When I do this, A becomes a reference to each of those V elements.
No. In line 22.
Yeah.
int my size equal to v dot size, and I use my size instead of v dot size.
Yeah. All right, so you mean that by using that memory location is going to be efficient?
Yes.
Yeah, well, maybe it could be efficient, but what I'm saying is that don't try to play those kind of tricks. You already have this. Okay, everybody understands it. You are saying that I can write code as efficient as this one. I'm not saying that no, you can't, but you have this already, and it works. By the way, this one work, and I can do this kind of stuff too. What does this do? What does this do?
Goes 2 by 2.
No, not at all. What does this do? Yes.
Right after increase.
It will print the values of vector v, and it will increment them by 1. I am taking a reference to each of those elements of v, right? So if I can compile this, can I compile this? Let me see if it compiles. And run it. Run, yeah. It says, okay, give me some numbers, 23, 24, 99, and minus 2. Okay, so it printed them out. Well, I didn't see it. Maybe I should have done plus I, because now in that case we can see it, right? And run. Okay, this one, and this one, minus 5. See, it is 34 you entered. Where is it?
You didn't compile it.
It did not compile? I just ran it, right? Is that correct? I did not compile it. Run. Okay. 20, 24, this, and okay, 23 became 24, 24 became 25, and 12 became 13. Okay? But this is not a good thing, right? No, well, this doesn't show what I wanted to show, because you might say that how do we know that the values of vector is incremented, right? Did I save it? I am out of time. Compile and run. Okay. 34 and 23 and minus 4. Didn't I compile it? What happened? You entered this. Anyway, you test it. I am out of time. I think I did not compile it. Anyways, okay. I'll see you next week.